In 2003, Category 2 Hurricane Juan hit Point Pleasant Park in Halifax, Nova Scotia. Point Pleasant Park is a 75-hectare area dominated by red spruce and red maple trees. Point Pleasant Park is considered a mid-successional stage forest, creating opportunities for plants to develop following Hurricane Juan. It is a regrowth phase that supports early and late successional species. Hurricane Juan destroyed between 70 and 80% of the trees within Point Pleasant Park. The storm created large, exposed areas with disturbed oil, increased sunlight, and substantial debris, completely changing the park's environment. Red maple trees are fast-growing in the exposed soil and high sun exposure. Encouraging the growth of species following the storm, red maple trees are considered an early successional species due to their high recovery rate following the hurricane. The numbers increased rapidly in the park as the park recovered from Hurricane Juan. Red spruce trees grow slowly and are shade tolerant. They are classified as late successional species because of their extended recovery period following the hurricane. Point Pleasant Park is significant for both its ecological value and its importance to the Mi'kmaq community in Nova Scotia. The park contains culturally important species such as the red spruce and historically the black ash, which has been used in canoe building, basket weaving, and other traditional practices. It forms part of the Mi'kmaq's traditional territory and preserves the history of their use of local plants. This impact of Hurricane Juan highlights the vulnerability of the natural areas and the culturally significant resources. The storm disrupted both the forest's ecosystem and its availability of traditional materials. These effects underscore the necessity of protecting and conserving areas of ecological and cultural importance. The objectives of the study are to determine the successional stage of Point Pleasant Park by analyzing tree density, tree size, and species variety over time following Hurricane Juan, and to evaluate its effects of external influences such as the urban environment and invasive species on the forest's succession and species richness. We hypothesize that if Point Pleasant Park is a mid-successional forest, then the density of early successional species, such as the red maple, will increase initially following the hurricane, but level off or decline as late successional species, such as the red spruce, increase in density due to their increased tolerance of resource competition.
For the methods section of our long-term monitoring of post-hurricane succession, we started the project with 6 permanent 20 by 20 meter plots that were established in 2004 in areas of Point Pleasant Park that experienced the highest structural damage from Hurricane Juan. These high-impact areas were selected to allow us to monitor ecological recovery and secondary succession over time. In each 400 square meter plot, all living trees that had a diameter at breast height of at least 2.5 centimeters were recorded. The primary equipment used in the field was a diameter measuring tape to measure DBH at 1.37 meters above the ground, which is the standardized forestry measurement height. Trees were identified to the species using a regional tree identification guide. After field collection, raw data was complied to calculate total tree density per 400 square meters, average DBH, species richness, Shannon diversity index, and Pelu's evenness. These metrics quantify both structural characteristics, such as size and density, as well as compositional characteristics, such as species diversity. To analyze long-term trends in forest recovery, linear regression was used to test for relationships between year and each community metric. Linear regression was appropriate because we were examining directional change over time, with a statistical significance that was determined at alpha level of 0.05. Results and discussion, question 1. For this, we're going to be looking at 3 different charts, the first one being the total density. Total tree density increased significantly between 2004 and 2025. Linear regression analysis showed a strong positive relationship between year and total density, with an R-squared value of 0.45 and a highly significant p-value of 3.9 times 10 to the negative 13. This indicates that approximately 45% of the variation in tree density can be explained by time since the hurricane. These findings support the hypothesis that density would increase during secondary succession. After Hurricane Juan removed much of the canopy, increased light availability at the forest floor promoted the recruitment of pioneer and mid-successional species. As a result, stem density increased over time as young trees established. This pattern aligns with the secondary succession theory, which predicts rapid colonization and increasing stem density following a major disturbance. Next, we'll look at the DBH chart. In contrast to density, average DBH significantly decreased over time. Regression analysis showed a negative relationship between year and DBH, with a statistical significant p-value of 0.0002. This decline reflects the influx of younger, smaller trees establishing after the hurricane. In 2004, the forest still contained some of the larger surviving trees. However, as recruitment increased, the growing number of small stems reduced the overall average diameter. This pattern is a characteristic of early to mid-stage secondary succession, where high recruitment temporarily lowers the average tree size. As these trees mature and competition increases, we expect the average DBH to increase again. Lastly, looking at the Shannon diversity, you can see that it increased significantly from 2004 to 2025. Regression analysis showed the positive relationship between a year and diversity, with the R-squared value of 0.33 and the highly significant p-value of 1.4 times to the negative 8. This indicates that species diversity increased as the forests recovered. Early after disturbance, communities are often dominated by a small number of opportunistic species. Over time, additionally, species established, increasing richness and overall diversity. This trend suggests that the forest is transitioning from an early successional stage toward a more structural and compositional complex mid-successional community. So, using that information that we have, based on the succession theory and our observation trends, the forest is currently in a mid-successional stage. As the forest continues towards a climax, Acadian forest community, total density is expected to stabilize or decline due to self-thinning, where competition reduces the number of stems. Average DBH will increase as surviving trees go larger and canopy closure intensifies. Shade-tolerant late successional species such as red spruce or balsam fir are expected to gradually become more dominant. Overall, the forest will likely develop greater vertical stratification and structural complexity, which are key characteristics of a mature Acadian forest ecosystem. However, because Point Pleasant Park is an urban park, continued management practices and future disturbance could and may influence this trajectory.
In 2004, the red maple is the dominant species. Its density is slightly higher than the red spruce during this time period. Although the red maple is more dominant, the relative tree density is fairly low due to the hurricane. The red maple shows an overall positive or increasing trend as the years pass. This may occur due to the early successional nature of the species. In 2004, just following the Hurricane Juan, the red maple has less competition and can dominate the park. In 2025, the dominant species is the red spruce. There is an upward trend since 2004. The red spruce increases in density steadily, showing gradual long-term growth. The red spruce is a late successional organism, allowing it to develop as resources become available following a natural disaster. As more early successional species develop and competitions for resources increase, the shade-tolerant red spruce gain advantage in growth over the early successional species, such as the red maple. The R-squared value for the total density indicates a moderate relationship between tree density and year, indicating that there is a correlation between the increase of years and the overall tree density following Hurricane Juan. As the forest moves towards its climax community, we can predict the red spruce to continue to increase in density or to stabilize at a high density. The red maple may stabilize or decline as competition for resources increase. The total density will stabilize at its carrying capacity. Why? Early successional species dominate first due to their limited competition for resources. Late successional species are slower growing, but outcompete the early developing species due to their ability to grow in highly competitive environments.
As we can see, at the moment, the density of both red maple, Acer rubrum, and red spruce, Pincia rubens, are increasing, as is the total tree density. This will affect red maple, Acer rubrum, and red spruce, Picia rubens, differently. As red spruce, Picia rubens, is a shade-tolerant species, it will continue to increase in density even under heavy shade, until, eventually, it will plateau, but more on that later. Red maple, Acer rubrum, is a sun-loving species and will eventually be outcompeted by longer-lived, shade-tolerant species. It will be forced to retreat back to its usual niche of living in deciduous hardwood swamps. The total tree density will continue to increase until it reaches equilibrium, where new trees are sprouting, but most are shaded out, unless there is a windfall or some such disturbance in the canopy. When this equilibrium is reached, probably not for 100 or 150 years, the density of trees will plateau. It is then that the density of red spruce, will also plateau. The Point Pleasant Park forest is a mid-successional forest. We see an increasing trend in the population of both red maples, Acer rubrum, and red spruce, Pincia rubrans. This shows that the forest is, slowly, developing into a climax, late successional, Acadian forest. Red spruce, Pincia rubens, is commonly found in climax Acadian forests, while red maple, Acer rubrums, is only found in deciduous swamps in the climax forest. But it is an opportunistic tree that is very common in early and mid-successional Acadian forests. The fact that both of these trees are still increasing in number indicates that there is still bare ground and a fair amount of light for the red maples, Acer rubrum, while there is an increasing amount of shade for the red spruce, Pincia rubens. Eventually, the supply of bare ground will be exhausted, and the red maples, Acer rubrum, will be shaded out and will be forced to return to the deciduous swamps, while the red spruce, Pincia rubrans, will continue to grow in number under shaded conditions, being joined by eastern hemlock, Thusca canadiensis, American beech, Ficus granfolia, and yellow birch, Betula allegensis. The increasing trend we see in species richness likely indicates that these species, common in late successional forests, are starting to appear in the locations under study. Because of the still increasing population of red maple, Acer rubrum, which on drier soils is an early successional species, while red spruce, Pincia rubrans, which is a tree typical of late successional forests, is present, we must conclude that the Point Pleasant Park forest is still in a mid-successional phase. Factors worth considering in the context of the conclusions on the previous slide include that Point Pleasant Park is an urban park. This will, in all likelihood, lead to it acting a bit like an ecological island, where species are unable to move between the wilderness that makes up much of the province and Point Pleasant Park. An example might be something like black ash, Fraxus nigra, which is a rare, critically endangered tree found in Nova Scotia. It is another tree found almost exclusively in deciduous swamps. Due to its rarity, it seems unlikely that the species is found in Point Pleasant Park. And if it is very unlikely that it would have sufficient numbers to form a stable population. It is also unlikely to spread to Point Pleasant due to the isolation of Point Pleasant amongst the surrounding urban setting. The lack of this tree will affect species richness in the park. It will also affect the migma, for whom black ash, Fraxus nigra, is an important species due to the annual growth rings splitting easily, making it the traditional choice for the interior ribbing of birch bark canoes and for basket weaving. The relative ecological isolation of the park might also make it easier for invasive species to dominate it. Already, at the Tower Road entrance to the park, Norway maples, Acer plantainoides, which are an invasive species in Nova Scotia, have outcompeted most native plants. The smaller population numbers of the native tree species in the park, and thus the likelihood for genetic drift and alleles to become fixed in the population more easily, might make it harder for native tree species to push back against invasive species such as Norway maple, Acer plantainoides, which ooze out toxins from its roots, allowing it to outcompete native trees. A mutation that could have allowed native plants to better survive these toxins is more likely to be lost due to the small population size of trees in the park. The Mi'kmaq practiced prescribed burns, which created a more open forest, which allowed for larger populations of game species. Although this would change the successional makeup of the park, as it would destroy such species as balsam fir, Abies balsamae, and American beech, Fagus gramfolia, and would favor such species as jack pine, Pinus puncella, red pine, Pinus regnosia, and white pine, Pinus strobus, and paper birch, Betula papifera. It wouldn't lead to the forest reaching a late successional stage faster. It would just reach there from a different progression of tree associations.